looking at. Today's, we're only going So we are beginning this naming polynomials, and the type of polynomials, like if it's a constant, quadratic, cubic, and so on, determines the shape of that polynomial. And to save some time, I'm just going to show you instead of having you get on the graphs and look at it yourself. A constant, remember that is like just a number. So if you have y equals c, we call that y equals c, y equals a constant. So if you have like y equals 5, y equals -3, you're just going to have a horizontal line that crosses through C. A linear function, what we call the parent function. So a parent function is like just the base before there's been any transformations, before anything's happened to it. A linear is y equals x, and it looks like this. A quadratic, y equals x squared. This is the variable function. We've talked about parent functions like briefly earlier. But a quadratic looks like this. Upside down, it could be wider, it could be skinnier, it could be shifted down. But this is the original parent. Kind of all seen before. A cubic, y equals x cubed. Alright, this is what a cubic function looks like. So just the original parent function. I'm also, in a different color, going to put another example of a cubic. So you might see a cubic more like this, where it goes up and down like a little more dramatically.
What's the difference?
Anytime you like add, so you have like an x cubed plus 5x squared minus 7. Anything that's added on to the cubic could change that. But just plain old y equals x cubed is this purple one. Okay. So a quartic, the same thing, y equals x to the 4th. That's just the very basic general parent function. And that one looks very similar to a quadratic. It's a little bit like wider, flatter on the bottom. However, that's not the way you will normally see a quartic. Okay, so I'm going to do another example of what a normal quartic might look like. Okay. Normally, you've got more like hilltops and valleys. They can look a lot of different ways. They can be skinnier, fatter. One hump can be real, like way down there, and another one up here. Okay. And then a quintic, y equals x to the 5th. The very original parent function looks very similar to a cubic. It would be hard to tell them apart. But what you would normally see is something more like this. What we're going to focus on today is what we call the end behavior. So if I ignore those top two and we just really look at those four, the left side, notice how the exponents are even numbers, and the right side over here, those exponents are odd numbers. Look at the ends, or where the arrows are. What do you notice about the arrows on the left side?
They're all facing up.
They're both facing up, right? And what about the ones on the right side?
I think up and down.
One's up, one's down. And that's what we kind of focus on. That's what we talk about for the end behavior. And so the end behavior, the direction that the arrows are pointing, comes down to two things. It comes down to the degree, if the degree is even or odd, and it also depends on if the number in front is positive or negative. So all of these examples, we had a positive in the front. We had a positive leading coefficient. We didn't see any negatives, but that'll make the ends a little different. So we're just going to do a little diagram here. If we have an even degree, that means that the arrows are going to point in the same direction. An even degree, same direction. If it's a positive, like both of these, both arrows are going to point up. So the left side points up, the right side points up. However, if it's negative, it's going to be flipped. They're both going to point down. So if I had done a negative x squared, this would be upside down. Or a negative x to the 4th, it would be upside down. So both arrows point down.
Teachers, at this time, please check your email from Ms. Susan and release those CTE students to the library at this time.
Is that us?
Alright, now if your polynomial has an odd degree, remember the degree is the largest exponent. If it has a large or an odd degree, they're going to go in different directions. So these examples that we had, those had a positive leading coefficient. This is different. What does the arrow on the left side do? Point up or down?
Down.
Down. So the left side points down, the right side points up. So that's with an odd degree, positive leading coefficient. All right, and then if the leading coefficient is negative, meaning there's a negative in the front, it's going to be opposite. It's going to be up and then down. You don't necessarily have to have this chart memorized because you could just graph it and look at the graph. However, this is kind of a quick reference if you don't want to spend the time doing that. So the way that we're going to write out the end behavior, we're not going to do two arrows. That's just kind of a guide. we're going to use what is called limit notation. You don't really have to know a lot about limits. This is a calculus concept. However, the notation is something I want you to be familiar with. So all that this does is it's telling us what's happening at the ends. So let me tell you what this says. This says the limit as x approaches, let's change this one to be negative infinity and this one to be positive. So the limit as x approaches negative infinity. What is negative infinity? What does negative infinity mean?
Infinitely going backwards.
Yes, infinitely going backwards. And on a graph, what direction, like, would that be up, down, left, or right?
Down and left. Oh.
Down. It's going to be one of them. So it's as x approaches negative infinity. Left. So as x approaches, that means left. So if you think about on a coordinate plane, on an x-axis, if your numbers are going to negative infinity, that means they're going like -1, -2, -100. That's going to the left. Think of it a number line. It's going to the left. Yeah. All right. So, and then over here will be like, it'll say f of x, whatever your graph is or whatever. And we're going to tell what's happening there to the y's. So, what is happening to the y's? If your arrows point up, your y's are getting bigger. If your arrows point down, your y's are getting smaller. And I'm going to show you kind of a couple of ways that you could figure this out when we get down to some real examples. So if your arrow points up, you're going to write a positive infinity there. If your arrow points down, you're going to write negative infinity there. So when I'm asking about the end behavior, you're going to write this. You're going to write the limit as x approaches negative infinity of f of x. That might already be part of your question. Equals, you're going to fill in this blank. If your arrows are pointing up, you're going to write positive infinity in that blank. If your arrows are pointing down, you're going to write negative infinity in the blank. And then the other one is talking about the right side. So, the right side. So you're going to write these limit statements 2 times. Once for the left, once for the right. So we're going to get into an example. Number 1, maybe the easiest way to do this is just to look at a graph. So I'm going to go to the Desmos calculator, and I doubt this will record on the video. So, maybe. There we go. All right, so I'm going to pause it. Now, you could also kind of do this kind of by just like plugging in numbers. So, if I plug in -1 for x, -1 store x, 4x to the 4th, plus 6x cubed minus x. I get negative 1. If I do negative 100 for x, so my x value got smaller. Negative 1 to negative 100 is smaller, but my y value got bigger. So on the left side, as x approaches negative infinity, or even if we look at the table, geez. Four x to the fourth, 6x cubed minus x. As we look at the table, if we go to in the negative direction, what's happening to your y's? They're getting bigger. All right, so lots of different ways we can figure that out. So what we're going to say is the limit, I usually do that in cursive. I just write limit, it's fine, as x approaches negative infinity. So this is just something, this is just part of your answer. The limit as x approaches negative infinity of f of x equals positive infinity. So as x gets smaller, the y's get bigger. This is just the fancy notation of saying that. When you see the limit as x approaches negative infinity, that just means on the left. We could have also looked at our chart to determine this. An even degree positive coefficient, which means they're both going to point up. So the left one points up to infinity, the right one points up to infinity. So that's the left, and then we do the same thing for the right. The limit as x approaches positive infinity of f of x equals something. So on the right side, the limit as x approaches positive infinity of f of x equals positive or negative. Is it going up or down?
Down. X was going down.
As x gets bigger, what's happening on the right side? What was the arrow doing on the right side? Pointing up. So it's infinity. Both arrows were pointing up, so they both should be infinity. Right here, this is really just what you're filling in. When you're asked for end behavior, you're going to write this every time. Both of these every time. This is saying what's happening to the y's on the left, what's happening to the y's on the right. Okay, we can look at the table as my x values get bigger, my y values also get bigger. Yep. Or looking at the graph, both of them went up. Or looking at the table, the little chart that we made, both arrows pointed up. So they were both going to positive infinity. Right, so let's look at another one. So number 2, we're doing end behavior. Let's go ahead and write both of our limits. So both of them, I'm going to write the limit as x approaches negative infinity. That's talking about the left. And then the limit as x approaches positive infinity. That's talking about the right. So on the left and on the right. You could figure this out several different ways. You could just look at the chart, which is nice if you have the chart handy. Okay, so this one is my degree even or odd. is my degree is the largest exponent. What's the largest exponent?
Positive.
Oh.
What is the largest exponent? 2. Is that even or odd? Even. Is the number in front positive or negative?
Negative.
Negative. So if I look here, even and negative, both arrows are pointing down.
Wait.
Even degree,
That's
negative leading coefficient, degree is the largest exponent, negative for even degree, negative leading coefficient tells me they're both going to point down. Or you can look at the graph. So I'm going to go back to the Desmos one. And you can graph it in your 84s, but it's easier to do graph stuff on Desmos. So if I do negative x squared plus x, notice the graph. See how both arrows go down? Can you see that? Both sides go down. So the left side, what are we going to put over here on the left side in limit?
Negative infinity.
Negative infinity.
Negative infinity on the other one.
Yep. Negative infinity on both. The left side points down, so we write negative infinity. The right side points down, so we write negative infinity. That's okay. All right, number 3. Let's go ahead and write the first part. The limit as x approaches negative infinity of f of x equals, and the limit as x approaches positive infinity of f of x equals. So the one that says x, with the arrow, x approaches negative infinity, we know that's on the left, because as x's get more negative, they go to the left. So we're looking on the left side.
It's becoming
So-
positive both sides.
So let's look at it. Let's just look at the graph. Y equals 2x cubed. So that's a positive leading coefficient and an odd degree. 2x cubed. Now I'm going to zoom out. Do they point the same direction?
No.
No. What's it doing? Down. What's the one on the right doing? Up. So the left side, we're going to write negative infinity. The right side, we're going to write positive infinity.
But I thought since it was like both an even degree and a positive.
It's not, the degree is 3. That's an odd number. Degree is the largest exponent.
Oh,
Degree is 3. So it's an odd degree. Positive.
gotcha.
Okay. Number 4 is negative x cubed. So let's go ahead and write the limit as x approaches negative infinity of f of x. Now if this said g of x equals, then I would put g of x there. So the limit as x approaches negative infinity of f of x. That's the left side. The limit as x approaches positive infinity. That's the right side. So we're saying, okay, if my x's get smaller and smaller and smaller, like I plug in negative 1, I plug in negative 10, I plug in negative 100, what's going to happen to my y's? What's going to happen to my answer? Or as I plug in positive 1, positive 10, positive 100, what's going to happen to those answers? Okay, so let's just go to the graph. I think that's the easiest way to see it. Negative x cubed,
Negative coefficient.
odd degree.
Yeah, I was right.
So what's happening on the left? On the left side, it's going up. So what am I going to write on this left one?
Positive.
Positive infinity. The right side?
Negative.
It's going down. So what am I going to write?
Negative.
Okay. Negative infinity. That's a bad one. All right, there's two more. I want you to try those two. So you can either... All right, so number 5, arrows. What's the left arrow doing?
Negative.
Down. So they're both pointing down, right? Down, down. So they're both, well, for both of them, you still have the limit as x approaches negative infinity. This part doesn't change. You're going to have that on all of these questions. So as x approaches negative infinity, that's the left, the y value goes down, negative infinity, and on the right side it goes down. What's the arrow? What do the arrows do on number 6?
Negative up.
Down and then up. So the left side is going to be negative infinity. The right side is going to be positive infinity. Okay. Number 7, we're kind of going backwards. We're looking at a graph. Is, on this graph on number 7, is the leading coefficient positive or negative?
They're both negative.
Of the equation is negative. Is the degree even or odd?
Odd. Wait, what?
The arrows go in the same direction, your degree is even.
Even, yeah.
Yep. That one's probably a quartic. Okay. Number 8, is the leading coefficient positive or negative? Yeah, this one's down up.
So down. Wait.
Is the leading coefficient positive or negative?
So it's down, up,
Positive.
positive, odd.
On. Okay. We'll stop there for today.